Thank you. Thank you. I'm very, very happy to be here. I've been looking for this moment for quite some months now. And, well, I think I'm very honored to be closing this conference with a little bit of music. So I'm not a programmer in the sense of, like you guys. I am approaching programming from the music point of view. So I'm a composer trained in the classical Western composition school. So I've been writing music for orchestra, for ensembles, for soloists, but also I discovered the computers since I started studying music. So live electronics in composition has been important, very important since the middle of 20th century. So we got the capacity to record sounds, and it implied a big change in the way we see music, not anymore as the music that only musical instruments make, like violins or pianos, but we include also now recordings of the street, recordings of many things. And as the machines and the technology for music has been developing, the composers have been there to including all these advancements in music. So I'm going to talk to you about my practice. It's called live coding. But first, I want to play a little bit for you some of the music I make. So talk to you like in 50 minutes. This was a little demo of a track I wrote some months ago. It's called Unbroken. So this was the version for today. So live coding is a lot about improvising, but we also need to sometimes make music for dancing or have some things prepared so we don't lose the attention. So live coding also can be having some code prepared, as you can see here. And then you manipulate certain things, certain values. So what you saw is the composition I made. So I know exactly what values and parameters I want to change during my performance. Okay, but I want to go now with the presentation I have prepared, because I have many things to tell you. So I better have this little thing in order. So, welcome. My keynote is called Musical Patterns as Functions. I studied mathematics. I kind of have an idea what a function is, but I am not a programmer, and I have a hard time still to understand what functional programming is. But I can tell you my point of view, and I think that's what I can do, is as a composer, having the idea of functional programming has been super liberating, and it has been the best way to translate my musical thought into a representation with machine language. So I'm going to talk about live coding, the practice I'm making, and I'm going to talk about TidalCycles, which is the main functional program software written for live coding. This TidalCycles is what has been more used, and we're now a quite interesting community, growing bigger and bigger. This is worldwide, okay, I'm going to go little by little. Live coding is a technique for writing and performing music in real time through creation and manipulation of computer algorithms. So there are many definitions on live coding. It's not that it's set in stone, but what we know is that we want to engage with algorithms in real time and let the audience know our thought process, no? And how do we solve things, how do we manipulate stuff. Live coding is also referred to as on-the-fly programming, just-in-time programming, and conversational programming. I'm sure some of you have heard about live coding. There was a live coding TV. So as a way to share software engineers and programmers sharing how do they do stuff, right? But so we have decided to make a big difference, establish a difference in the fact that we, with live coding, are making a performance, yes? So live coding makes programming an integral part of the running program. Okay, it is a performing arts form and a creativity technique centered upon the writing of source code and the use of interactive programming in an improvised way. Improvisation is very important here. Okay, I will talk later. And also this name, Alex McLean, we are going to talk about him a lot today because he's the writer of TidalCycles. He's from the UK. And he has said, he has written several good papers that I will recommend to you later. Live coding is a new research domain where computer science blends with the performing arts. And this is key in our practice because me as a composer, if I didn't have my friends, my colleagues at the live coding community, which helped me learning programming, which solved my doubts. I don't know how to write a function for something. I know how it works in music, but I don't know how to translate this. And they, on the other hand, they know how to write, but they have maybe no musical knowledge. So this is a multidisciplinary, a multidisciplinary community. So we need each other a lot. I always say a live coder is never alone because we need to be active in sharing our knowledge. So if you're interested in this, we have many forums on the internet, especially LORC. We used to use Slack for a while, but the community is very active. It's a community worldwide. It's very inclusive. We have a lot of women, a lot of people who are not musicians, not programmers, but architects, philosophers. So this is something that live coding has brought about, the need for multidisciplinarity and sharing our knowledge. So the main site for TopLab and everything related at live coding is TopLab, toplab.org. That is our organization, let's say. You also see a little logo with the computer and little heads listening at the performance of the lines of codes. So Top Lab is where we have everything more or less described, what we are doing. And I want to show you the manifesto. We have a draft manifesto. And here are some points that I want to share with you. Give us access to the performer's mind, to the whole human instrument. It all came about because we have seen performers with laptops, especially DJs, and we just see them there, or Kraftwerk, we really don't know what they're doing, no? And we trust they are making the music, but some of them are just putting play and just staying there. So we decided as live coders to share our screens so you can see what's happening, and if we make a mistake, how can we solve it? Or, as it has happened to me, I have had errors, and then someone in the audience tells me the solution, no? So that's a very interesting way to see music in a new lens, because we as musicians are trained to not bring errors to the stage. That's why we train for so long, for so many years, right? But then we have here the opportunity to be vulnerable, the opportunity to show our mistakes, and that makes the whole instrument. So the computer is a musical instrument. It has been for so long, since middle last century, it has been a music instrument. Now our laptops are super powerful music instruments, but it would be nothing without loudspeakers, without me showing you the screen. So this is my whole instrument, yes? Show us your screens. This is our main motto. It doesn't mean that you have to always show your screen. If you don't want to, you're free to not to. But it's preferred. That way we can show how the live coder, the composer, makes their own music. We can have 3 live coders using TidalCycles, but everybody uses it in a different way. So what's very beautiful about this is that we're not consuming as a commercial software which has already everything prepared, and even if it's amazing what it can do, still you're thinking the way these guys designed the product that they sold you. With live coding, we're talking about open source software and community. So it's a very, very wide, it offers a very wide spectrum of possibilities for a musician to be unique, to create their own sounds from scratch if they want. And not only the sounds, which we can describe with algorithms too, like these are sounds I have designed in Super Collider. This software is central for the live coding practice because it's open source, and it's a composition environment in real time, written by James McCartney in the 90s. And he made it open source once he got a job in Apple, so he liberated this. And it has been a big resource for all electronic and computer music composers. Are you listening to me well? Is my accent everything okay? If anything, you let me know, please. Okay, so we can design our own sounds with functions and algorithms, but we also can display them in time, sequence them in time, and that's why we use TidalCycles, because it is thanks to Super Collider that the idea of performing live music came about, because Super Collider became fast enough to make the changes as the program is running. But then when you want to sequence the sounds, especially for dance music or beat-based music, Super Collider can be a little tough for that task. That's why Alex McLean came up with the idea of using functional programming as a way to trigger the sounds we have created in Super Collider in a much more powerful, efficient, organic, natural way. So this is a very good opportunity for musicians who want to create complex behaviors coming from very simple structures. So this is what I think the fact that TidalCycles is functional brings all these ideas that you can make functions. You don't. This is TidalCycles is patterns, so we're describing sounds with patterns. But the ability to have functions in different places, in different parts of the structures, makes it very interesting to make complex behaviors with little words and with what we have here. Okay, so go back to my little top lab. Is our website, so I recommend it if you're interested in this. There is also okay, right now I don't need to show you this one right now. So as a musical instrument, before, when we were using computers as musical instruments, we more or less had always this idea of the graphic interface. And software like Pro Tools, Ableton Live, very well-known software for music, all of it is graphic. So it's like you're imitating the idea of a recording studio where you push a fader to turn up the volume. But now we are free from the 3D paradigm idea of that only the higher is the higher number, so the more volume, or that we need to connect one box to another box with a cable. We don't need to do this with the computer. That's not the only way we can do music with the computer. So now we have code, where all these abstractions from the 3D reality can be completely changed, no? So we have numbers and we have functions and we are dealing with the translation of our musical thought into the language for the machine, no? So we are describing our music with written language. This also brings about that the code is very beautiful to look at. Actually, that's why I started to get into code, because I love words and I love the way it's seen together, and with all the colors, I was always fascinated. So it really has an aesthetic value, and for artists, that's amazing. So right now I'm working with a visualist from San Francisco, but she lives in Bogota, Colombia, where I was born, and we're working together. And she has written a video software inspired in video feedback, so for live coding. So she can take my code, so I send it with the Adam. I send her my code, and she can make her visuals with it. No, so the aesthetic possibilities of code is very interesting for artists. So the page can become a space for sharing ideas other than the code. For instance, I just wrote "thank you." No, I can communicate with my audience. I am normally quite shy, so I prefer to type instead of talking. So that it becomes also a way to communicate with the audience. It has a lot of visual expressivity. So yeah, this has been used by visual artists, poets who make live-coded poetry, choreographers. So this practice was born in the academic music scene in England, and now it has expanded to many different disciplines and countries. So I want to mention a little bit about algorithmic composition. This is a big subject, so I'm going to name some of the some important names to keep in mind. Of course, since the Greeks, and even before that, like music is mathematics, so we can describe music algorithmically, and it has happened since the beginning, right? Even traditional musics, they have their own algorithms, even if they don't describe it with mathematics. They know, for instance, pan flutes in South America, that they can play and create a pattern between 4 or 5 pan flutists. They create a melody. He knows he plays first, he knows he plays the second note, the other knows he plays the third note. And that's an algorithm that was passed generations, African music. So the algorithmic nature of music has been there always. But let's think about the Western classical tradition where I come from, or what I was trained into. Guido d'Arezzo, he's a theorist of the Middle Ages in Italy, and he developed a system to teach the singers melodies in an easier way. So he found ways to describe melodies with the phalanges, and I don't know it very well, but in Wikipedia, if you're interested, you can see it. So this was a way to using an algorithm to teach music. And by the way, he's the one who named the notes as we know it, do, re, mi, fa, sol, la, si. I know here is different with letters. And, well, yeah. And he's really the one who brought about the modern music notation. So thanks to him, we have the 5 lines with the notes. Okay, let's jump to Johann Sebastian Bach, 17th century. Recent research have showed that he used a lot of magic squares. So, of course, any kind of music can be described with algorithms. It depends on the rules of the music. So we at school, we were taught how to compose, how to make counterpoint in the way of Johann Sebastian Bach. But what we did was have a long set of rules to describe that music, right? But then it turns out he used magic squares that gave this result. So that's very interesting to know. Mozart, 1 century later, he used automated composition techniques, especially in his dice music. So he had a set of dice, and for each phase of the dice, he had a part of melody. So he could compose long lines with just throwing the dice. And that's something that many composers have been using forever, no? John Cage, American composer, one of the most important. I really recommend it to you because he brought many important new notions to music. Like for instance, if we listen to what's happening right now, if we listen to my voice and the air conditioning, maybe a dog or something, we're listening to music. Just the fact that we are listening, it gives an intention. So if we think that music is the art of sound, what is art? Maybe it's just an intention. So that's what he said. John Cage said, everything is music, everywhere is the best seat to listen to this music. And he also brought many theories about indeterminacy and randomness in music. So for instance, he took a chart of the skies, of the constellations, and then he superposed pentagrams. And he just was marking notes where the biggest stars were. And this is what created a melody for him, for instance. So we have been having a development and the use of algorithms for music and automated processes for music. But also we have been having widening of our paradigms in terms of what is music, no? Is only music coming from an orchestra, or is music something that I can, any moment where I can enjoy sound, no? And then we have another composer who used algorithms, was Arnold Schoenberg. The serialism started in Germany and in Austria in the 20th century. And what they did, they wanted to end the idea of tonal music. We need to find another way to make music, not only tonal, that it always ends up in the same chord and it goes to the other chord. Like, we need to break rules, and that's what he did. So what he did was he created different patterns for different parameters of music. So for instance, melody. He had a whole matrix of data to treat the melody, and another one to treat the rhythm, and another one to treat the dynamics. So this is algorithmic music that was written, like the matrix, they did it by hand. So they were filling each number and then selecting them by hand. But I always wonder what they would have to do if they had a computer like this, these composers, with such an amazing capacity for computing, no? Because anyway, they were computing, either with the dice or with indeterminacy, but if we have a computer that calculates way faster than what a musician can do, so this is what we are, with live coding, bringing about all this history of algorithmic music, but we want to do it in a live manner. So we have, like from the middle of the 20th century, computers became a big thing for composers. We had some computers at the universities, and some composers were lucky enough to get time with them. And we have, for instance, Yannis Xenakis, Greek composer, then moved to France. He had a lot of pieces in which the computer was assisting his composition. The computer is not creating sound, but it created a lot of data from the functions he was giving it. And with this, he composed a lot of works. It's genius. So I really recommend, if you're into like getting inspired from musicians, I think Yannis Xenakis is a very good mind to look into it. So with the computers, we can have stochastic processes in a very wide way. Of course, we can have now people researching on artificial intelligence and machine learning. So I'm sure in a few years, I'm going to write a little piece of code, and the machine will know what I mean. So it will save me a lot of code. And of course, we can implement different processes in our music. Okay, we were talking before, the live coders deal with algorithms during the performance, changing them, deleting them, writing new ones. Live coders improvise. Live coders write, rewrite, and manipulate in real time a system that creates music. Still, live coders are the composers of the music. And this is another thing that live coding has been showing and shedding a bit of light into. If we use a system, do we stop being the composer and then the machine is the composer? So this is an old discussion. I think that we are always the composers. And the software actually can become a composition itself, or a piece of art itself. Okay, live coding emerged in the academy in UK by this mixture, a very good mixture of artists and computer scientists. So I think it's always good to mix with different people to get new ideas, because nobody knows everything, and it is good to complement each other, right? And this is exactly what the live coding community is about. And it's not tied to a specific genre of music. So I started with live coding because I'm an electroacoustic composer, so I make abstract music, textural music, very much in the John Cage school. But then this appeared, the Algorave, which is a portmanteau of algorithmic rave. And it was a joke that Alex McLean and Nicholas Collins, two guys from England, they were driving one day, two live coders, composers. No, I'm kidding. Alex McLean is a computer scientist, and Nick Collins is a composer. And they were driving one day, and they said, hey, imagine if we did live coding, but in a club to make people dance. Yeah, that would be funny. Okay, now we have, I think, almost 1,000 people worldwide doing this. And we have, it's a very active movement, growing and growing. So if you want to see what these people do, the Algorave.com is a good Algorave. So you can see we have had Algoraves in all the world. It's really good. And you can see some artists here. And we have our YouTube channel called Euler Room. It's all jokes, but then it's really You know, it's well known, like 431 subscribers. So here you can see every year we celebrate our anniversary, we make a streaming online. So we take over our channel on YouTube and we have a listing with the schedule and everybody in the world can participate from home. So here you can see what a lot of people is doing. Let's just see just a little bit example of one. She's from Iran and she lives in England. She makes her own visuals and her own music with TidalCycles. So this is normally what an algorithm looks like. A bunch of guys who love computers and music get together and we try to dance to very weird music that is not like the music we're used to in a club. But it's so beautiful to see how everybody writes their own algorithms in a different way. So you learn about music, you learn about programming, you get drunk and have fun. That's what an algorithm looks like. Okay. So what I played earlier was actually one of the sets I would play at an algorithm. No, it's a bit techno. Strange techno. Okay, so welcome to TidalCycles. As I mentioned before, it's a free and open source software, free open source community. If you're ever interested, please join us. If you go to the TidalCycles website, I will show you Mike Hotnick from Minnesota. He's one of the top live coders in the United States. There are not too many still, but it's growing, especially in New York. We have a community of live coders. This was in one of the international live coding conferences. I'm going to leave it a little bit so you can see. And for musicians, you can see certain things like note, portment, cut off. So you can see so many variables that for musicians are very well known. Sound, samples. So even if the audience doesn't know how to code, we want to make the interaction with the code as obvious as possible. I mean, people know that they are typing, and when they run the code, there's some change, and that's the important thing. So as you see, he has some things prepared, and then he improvised a little bit. I'm going to go on. It can be really fun. An algorithm is really fun. But of course, we have live coding for... could maybe show you. No, I'm not going to improvise too much because we don't have a lot of time. But I'm an improviser. Okay, so this is taken from Alex McLean's paper on his software, which for me is very complicated still to understand, but this is what I could understand, so I'm going to share it with you. In TidalCycles, time is structured in terms of metric cycles, a perceptual phenomena that lies at the basis of a great many musical traditions, including Indian classical and electronic dance music. So definitely Indian classical music for him was a big influence. That's why in TidalCycles we think in music in terms of cycles, no? Different from the training in the Western world, where we have a beginning and an end, everything is linear. So here we have the chance to think in music in a different way, from the conceptual point of view. TidalCycles timeline can be conceptualized as a spiral, both repeating and progressing. Building and combining patterns is the name of his paper that I want to show you here. I think if you're interested in this is a good paper to read. I want to show you how he sees the representation of the cycles, no? The tidal timeline is an infinite spiral. And here it gets very technical for me. But when he started writing the software, he did it visually. So he wrote this kind of patterns, you know, visual patterns. So what's important here is how we can create a pattern, how we can change it. So this is something you guys would know what it is about. I really want to learn what a functor is. But then why a musician who knows nothing about these things want to learn? And I think one of the things is that learning it is quite easy. Anybody can. When I teach workshops, in 1 hour workshops, you can start making basic music, because let's say I establish like a track. We call it string. This is the D1, and then I say in the D1 we're gonna have the sound bass drum. So cycles per second. Usually the program comes in cycles per second. 1 cycle per second, which for musicians is 60 beats per minute. But my techno I was playing is a little faster, right? And if I want it 2 times in a cycle, I just multiply it by 2, right? Or I can have 2 instruments. Okay. Now I have 3 elements in my pattern, right? Now my pattern is divided in 2, so I have 1 cycle of 1 second with 4 elements. And if I want to multiply this 1 by 2, right? So just with this, you can start making music right away. Yeah? And then what if you superpose another string? Let's say the very well-known 808. What if I put 4 of them? I can't almost listen to it, so I can turn up the volume with gain. Normally it's 1. Let's see a little bit louder. And so what we do, TidalCycles started as a sample-based program. So we have here a whole list of samples we can use. No? Everybody can use their own samples. What was I going to say? Yeah. But then many composers were using Super Collider, designing sounds. It takes so much time to design sound. And we wanted to control Super Collider with TidalCycles. So many of us told this to Alex and some Super Collider developers, and they came up with the idea of joining them. So what we're doing is we can use the samples, as usually you do with TidalCycles, but you can also trigger the sounds that you have developed in Super Collider. So let's say I want to call my synthesis I made. It's called Robo1. So that's my own beautiful sound. Right. So now everything, all the sound comes from Super Collider, which right now is the best tool for sound, but we are controlling it via OSC from TidalCycles. So TidalCycles is a trigger. No, it triggers the sounds with different functions that we can make. So let me see what I had here. And yeah, we still have some time. Yeah, cool. So patterns in music. Repetition is central, is the heart of music, right? The thing is that in some Western schools, especially with Theodor Adorno, I don't know if you heard about him, but he said that music, that repetition was the most terrible thing that could happen to music, and only traditional musics could do that, but So there was time in the 20th century was repetition in the academic circles. Repetition was almost banned, but repetition is part of music. It will always be. It's a very important part of music. That's why TidalCycles is written mainly to repeat. So you can think of a loop, of different loops that are always coming together. And you can treat these patterns. You can use the symmetry, for instance, reflection, rotation. You can interfere these patterns, make them change, and you can deviate from the pattern, which is also very important in music, because if we always hear the same pattern, we get bored very easily. So musicians, our quest is to learn to keep people interested. And so we want to break the anticipation, we want to cause surprises. That's also as important as repetition itself. So I want to show you a little bit of an example. Let's take this one. Our beautiful beatbox we just made. And then we can put a function here that says, you know what, play it in palindrome. Right? But you know what, that's boring. Let's do it only sometimes. Right? And we can say, okay, but you know, every 4 cycles, increase the density 4 times. That's not very beautiful, but I just wanted to show you how it works. Okay, and let's say another one. T4. Sound. New notes. I need to check on my folder because I don't remember how many exactly do we have. Aha. So when we call this sample, we're actually calling the first one. What if we wanted another one of the folder? So we write new notes. One would be the second. Okay. New notes. And I'm going to tell you that striate is chopping the sample in 8 parts. So now each note is divided in 8. Let's say like every 3 do that process. 8. So that's the basic functioning and the basic syntax. So we have here the functions that transform the pattern itself. And then we have here we can add some effects, like gain, so the volume. And maybe we can also add a little easy filter called vowel. We're just adding a filter using format values, like the values of our vocals. So this was very used in the 50s when they were trying to emulate the human voice. So it's very valuable for live coding because you just write vowel I and you have a different color. Okay, what time is it? I want to leave time for questions. So I'm going to show you very quickly a melody that Alex wrote when he was explaining me how he made his melodies. So I write the notes here, right? So I have this instrument, it's a synthesizer written in Super Collider, and I can give it the notes here. But then I can do this offset. Right? We have different rhythmic patterns here. We have little pictures. As I said, it is not tied to a certain genre of music. You can create new music. And me as a musician, what I find is that live coding offers big opportunities to rethink what music is, to rethink the roles of the composer and the audience that we were taught in classical Western music, especially where we are like the ones here and you're there and you're not supposed to know what's happening in my brain or if I make a mistake, no? So live coding is like breaking all these paradigms and everybody can be a musician if they want. And I don't consider myself a programmer, but in a way I am because I'm programming my music, right? So I'm also have the chance to become a programmer thanks to this practice and thanks to this live coding community from around the world, which is very inclusive and you can ask anything anytime you want. So if you're interested in expressing yourselves or helping us with ideas, please, you're welcome anytime. I hope you like this. Thank you very much. We have 5 minutes for questions.
Thanks, Alexandra. I was wondering, do you ever find yourself wanting kind of a hybrid between, with both GUI and text-based interface? Do you ever find yourself wanting a combination or a hybrid of the text-based interface and a graphical user interface?
Me, no, because I am so in love with the software and with TidalCycles. I'm like devoted to this. I haven't even played my guitar in a long time because this is my new toy. But a lot of people do. So you can see many live coders controlling analog synthesizers, for instance, using the patterns of TidalCycles. Or as I have done, I have written for accordion instruments. So there's not limit, and everybody can do as they please. And if you go to a live coding conference, or if you look on the internet, you will find many examples of how can things get connected.
So you just mentioned how people they use the TidalCycle sequencer to control their synths. Do any people try and go the opposite way, where they have a MIDI controller that can maybe control some of the variables in your application so that you can have some live interaction with it or expressiveness there?
Yeah. I haven't seen it with TidalCycles, but I have seen it with Super Collider. Actually, I was doing that because before TidalCycles came to my life, I was playing the electric guitar a lot, and I was making my own effects here. So I was actually using the guitar as a controller for all the things I had programmed here. So depending on the volume, on the frequency, I had pitch followers, and so that's how I used it. But I'm sure this is an area that can be worked and developed more. So if anyone is interested, please.
I'm really just curious, but has any music that's been done in this algorithmic style, specifically using TidalCycles, kind of hit the mainstream yet?
I think so far our most mainstream guys are Rennick Bell. He lives in Japan. He's from Texas, and he has been playing a lot. He wrote his own software in Haskell. It's called Conductive. So if you go, yes, I have here. Where is it? Okay, but if there is a list of in the GitHub of TopLab. GitHub. We have a list of softwares that some guys in Argentina put together, all things live coding. So github.lab, awesome, and you get there. So if you have questions, here there's a lot to do, to see, and this is a list of languages. So Rennick Bell, he wrote Conductive, a set of Haskell libraries for live coding and real-time using applications. Well, now he's really getting into big tours and stuff. So little by little, we're getting there. Not mainstream yet. 65 Days of Static is a band from England. They were the ones that made the music for this Infinite game. And what is the name? No Man's Land? No. What's the name of that? This Infinite video game? 65 Days of Static. They use TidalCycles as part of their performance. So you see they have the pianos and everything, and they have a little stand with the laptop for when they want to go and other things. Yeah. It's a long way, but...
Is there a way to record a MIDI stream of the output, so that while you're live coding, it could be recording all the events as MIDI, and then you could recreate it later by playing it back?
Yeah, I don't know how to, but yes, of course, definitely. I think it's very simple here in Super Collider with some MIDI class. Yeah, it can be done.
Any other questions? Oh.
Is there a culture of playing each other's music in the Tidal community? You know how I might play like a classical composer's work or a jazz composer's work? Is that possible?
It's definitely possible. I think it's not happening because we're so eager. It's such a liminal state. We want to discover and create our own music. Maybe we have been, there has been some remixing of codes from other people. We have done that. But so far it's not been very much explored. But and covers also, I haven't heard much. I saw a girl 2 months ago in Latin America, a girl from Brazil. She was playing some samba in TidalCycles, and then she was singing a very famous samba song. So yeah, I think the limit is imagination.
The piece you did at the beginning, you'd obviously done a lot of preparation on the different channels. How often would people publicly just get up and have a completely blank screen and create the thing completely from scratch?
Yeah, actually we call it the Mexican style when we start from the beginning. And the story is that I was living in Mexico back then, like 10 years ago, when we first heard of live coding. And they were like, okay guys, they are doing this in England. You have to start from a blank page. And so we were doing this, and we were meeting in a kind of meetup, no? And we had only like 2 hours. So what we did was divide the amount of people into the time we had. So it turned out that it was 9 minutes for each one. And so it became the rule, like every time we were going to play from scratch for 9 minutes. And at the beginning it was crazy. You were shaking, and it was taking so long time to make it bang. But once it sounded, everybody was, yeah, I don't know. It's very, very exciting. So you can do any way you want. I love to keep the coding, the life aspect live, and bring out about improvisation. But I also have my particular way of programming involves a lot of uncertainty and determinacy. This is not it, but so I have a lot of sometimes in this case. And actually my own sounds have a lot of things that you can, stochastic processes inside, so a piece of mine will never sound the same. Even if you can recognize it, it will never sound exactly the same. So that's something that generative music can bring about with computers, and live coding specializes in how to do these processes live.
Hi. There's a famous visualization by Malinowski of Chopin's Lullaby that sort of shows the notes as you play them along, and they're toned by color and things. It's very interesting. But are there any sort of like plugins to help you sort of see what's going to happen in the next moment in these cycles? So not so much a purely aesthetic visualization, but almost like an interactive, a graphic. That makes sense?
I think there has not been so much interest in going like back to the graphic thing. But yes, actually Alex McLean wrote a piece in which wrote software in which you could see how all these patterns were coming together, and they were moving like little squares of different colors. But now, I think what's happening more, yes, definitely it's possible, and I'm sure some people is going to do it. But right now what's happening more is the idea of visual and sound come together as two independent art forms that come together in live coding. So there's a lot of visualization there too. But for me, I love it to be without graphics. I just want to make sure that the sound is sounding. In a performance, this kind of meter is very important. But other than that, I really enjoy my letters and my colors, and other than any visualization. But there are many softwares for live coding, for visuals of live coding, in which you can create a lot of this. Any other questions, ideas? Well, thank you very much. This was very nice.